Synthetic division is a wonderfully quick way to divide polynomials, but the reason we don't start off learning it is because it only works some of the time. So synthetic division only works for linear divisors. What this means is that the exponent can't be greater than 1. So if you look here, this is just a term of x to the 1, x to the 1. If you had a big long polynomial and it was being divided by x squared minus 2x, this x squared is a quadratic. It is not linear. And so therefore it would not be eligible for synthetic division. Now, we are going to do it just when our first term is an x and it has no coefficient other than 1. Technically, you can kind of get away with doing it for other problems, but this is what we're going to do. So the way it's set up, we're going to write some of these things up here. Step 1 would be to write down the coefficients. Write the coefficients of the terms. So in this case, we've got an x, a 1, a -9, a 23, a -15. That's what you would be sort of writing down. And I'm going to give you an example of what this is going to look like. So we would write the coefficients sort of whatever they may be in these spots. All right? This spot here is reserved for the divisor. What are you actually dividing by? And because it's in the form of x minus a number, it's going to be the opposite of what you want to say. For example, in our problem, it's x minus, and what's left over is just a 5. And so you would only put a 5 in, not a -5. It's basically the opposite of what you want to write. We're going to put in a little line for adding. You're going to always, this is a remainder box, so let's just write that in there before we forget about it. You're going to always bring down the first term. Bring down first term. And once you've done that, you're actually ready. You have your setup done. Now you're ready to do the synthetic division. And we will do both of these examples. It'll make much more sense. But what you do is you take this divisor and you multiply it by the numbers down here. So we're going to multiply divisor by each number in these positions. And you write them here in these spots. In these spots, what you're going to do is you're going to add these terms. Now, it all looks very complicated and messy, but it's actually going to be very, very quick once we go to try and do this out. So let's see how this would work. I wish we had a little bit more room to be able to see the setup that I have over here and what's below. But the previous recording showed that it's just too small for you guys to see if we do it that way. So step 1, let's write down all of our terms. So we're going to write down there's a 1x cubed, there's a -9x squared, a 23x, and a -15 as our constant. We are dividing by a 5. We're going to scoot this down just a little more to see if you guys can see the rest. We put our remainder box. We bring down our first term. We are now ready to start this problem. So if you remember from above, we are going to multiply this divisor by any number that's down here. 5 times 1 is 5. Then you add these together, -4. 5 times -4 is -20. Add these terms. 5 times 3 is 15. And hooray, we get a remainder of 0, so we don't have to concern ourselves. Now you might be wondering, well, what the heck are we going to do with this 1, -4, and 3? And that's simple. What we do now is we started with an x cubed, and we divided by an x. So it means we are going to start with an x squared and just cruise our way down. So this 1 is 1x squared minus 4x, and if there is no sign, you put in a plus sign. So the answer is x squared minus 4x plus 3. To really illustrate the magic of this, I want you to keep your notes in front of you. And I'm going to go back and show you this same problem that we did in class. So keep your notes and take a look at this. If you see, we have the 1's, which we had brought down. Then we have -9, +5, and a -4. The next column is a +23, a -20, and a +3. And the last column is a -15, a +15, and a 0. Synthetic division does what long division does, except it does it without any x's and without having to subtract and change the signs of everything you just wrote down. So it makes it very simple and far less messy. So we're going to come back to this. The only time that synthetic division really tries to trip you up is when there is a hole. So where it says careful about the holes here, the only time the hole is going to cause trouble is in this dividend. We're going to take a look, and it's almost better to say the coefficients out loud. If we start with an x cubed, we need to have a coefficient for every version of x. So we have 5 x cubeds, but we have 0 x squareds. You must hold that place. You have 3 x's, and you have -8 as your constant. Take a moment and guess. What do you guys think we should write in this divisor spot? Remember, it's the opposite of what you want to say. If you guessed 1, you were on the right track. We've got this set up. Take a look at what you have written above there and decide what should we do first. We're going to bring down the 5. And now we're going to multiply by all of the numbers that are down here. 1 times 5 is 5. Add. 1 times 5 is 5. Add. 1 times 8 is 8. Add. It comes out again, no remainder. Wonderful. So now it's time to put in the x's. We had an x cubed. We divided it by an x. So we're going to start with x squared. 5x squared plus 5x plus 8. And that's our final answer. I suggest using synthetic division on a few of those problems, especially when they, you know you can do it quickly. Check back for more notes on our next section, and we'll see you in class.